In this video, we'll take a look at how to create a table of ordered pairs for an equation that's not linear. Okay, so and that's a little bit harder, right? If there's some curviness to it, or a maximum or a minimum or something, we don't necessarily know where it is. And if we just pick random values of x, how are we going to know that we've seen it all? That's one disadvantage to plotting something with points like this. And I know what a lot of you are thinking. Can't we just plug this into Desmos? We know how to do that. It's pretty simple. Yes, we can do that. But also, again, we're just trying to get just an overview of what does Desmos do? What are the, in terms of a value of x and a value of y, and what does it do with that? So in this example, we're going to create a table of ordered pairs for the following equation and make a plot of the equation. All right, so as you choose a table of values, you can pick some values, and I look at this and I say, well, it's a quadratic, so I know it's going to have at least one maximum or minimum to it, right? So if you just start picking some values, like for instance, I'd keep it close to 0 at first. Maybe you want to pick -2, -1, 0, 1, and 2, right? Now, maybe these aren't even going to be helpful, but we can just try it. Okay, so when x is -2, y is, let's see, negative times the quantity -2 squared minus 3 times -2 plus 5. Okay, so -2 squared is 4, but we have the negative out in front, so we have -4. -3 times -2 is +6. And then we're adding 5 to that. So -4 plus 6 is 2. 2 and 5 is 7, right? Okay, so when x is -2, y is 7. So the ordered pair is -2, 7. Okay, so when x is -1, what do we have? Negative times -1 squared minus 3 times -1 plus 5, right? I'm just sticking in the -1 everywhere I see an x in the equation. Okay, so -1 squared is 1, but we have a negative out front. So -1, -3 times -1 is +3 plus 5. So -1 plus 3 is 2. 2 plus 5 is 7. Oh, isn't that interesting? We have -1, 7. Okay, when x is 0, most of you can see by looking at that what it's going to be, right? -0 squared minus 3 times 0. So we have 0 minus 0 plus 5, right? So y will be 5. Okay, so the y-intercept is 0, 5. Now, before we go any further, I'm curious. I want to plot these points. I've got -2, 7. And -1, 7, and 0, 5. So for 2 points to be on the same horizontal line that way, that tells me that there is a maximum or minimum between those two values. So, and I know if it's coming down here like this, like I don't necessarily need another value out at x equal 1 or 2. So I'm going to change these values a little bit just based on what I've just found out. I kind of want to know what's going on out at -3 and maybe -4. All right. So if x is equal to -3, I'm going to have negative times the -3 squared minus 3 times -3 plus 5. Okay. -3 squared is 9, but we have a negative out front, right? So -9, -3 times -3 is +9 plus 5. So -9 plus 9 is 0, and then we're adding 5 to that. So -3, 5 is a point on the graph. And while I'm over here, when x is -4, I have a negative times the quantity -4 squared minus 3 times -4 plus 5. Okay, so -4 squared is 16, but we have -16 because of the negative out front. Negative 3 times negative 4 is positive 12 plus 5. So negative 16 plus 12 is negative 4. Negative 4 plus 5 is 1. Okay, so the point negative 4, 1 is on the graph. Okay, so let's continue to plot these. Negative 3, 5. We have its companion point already in the y-intercept. And then negative 4, 1. Okay, so now I know halfway between negative 2 and negative 1, this has some sort of a maximum, right? We don't know exactly where it is, but based on what we do know, we've got this parabola, it opens down. So we were able to get this graphed, a rough sketch of it, even though we don't know exactly where that maximum is. And that's a downfall of just simply plotting points. If you don't know anything about the main features or characteristics and where those are located, plotting can be more cumbersome. But it is a method that will always work to find points on a function.